So if two events, we say they are, oh, what happened? If two events are mutually exclusive, that means if they have nothing in common, for example, you need to go over all these slides and understand the rules of probability. The probability of any event is the sum of probability of outcomes for the same event. The complementary or the complement probability, which is called PA, see here is 1 minus PA. PA is the probability of event A. Okay. Rule 3, if event A and B are mutually exclusive, we said there's nothing in common between them. So the intersection between them is 0. So probability of A or B is equal to probability of A plus probability of B. Actually, the probability of A and B, we said, and B is 0. So nothing in common between them. If two events A and B are not mutually exclusive, so if they are not mutually exclusive, so the probability is equal probability of A plus B minus the intersection between them. Here, there's no intersection, right? So that's why this part was 0. Here it's not 0. Conditional probability, if we have probability of A given B. This, we read this as probability of A given B is equal to the probability of the intersection between A and B and the probability of B. Okay, this is the probability of A given B. We read this as A given B. So I might ask you, oh, what's the probability of A given B? So you need to know that this is the rule for probability of A given B. So if you cross multiply, so probability of A and B is equal to probability of A given B times the probability of B for this one, right? This is sometimes we calculate the probability using the tree, you can do that, So production is not defective, for example. Product is defective. So if it is if not defective is 99%, so defective is definitely 0.1%. So this information usually given independent events. If we have two events are independent, so probability of A given B is equal to the probability of A. That means that the occurrence of A will not affect the occurrence of B. So it doesn't matter B occurs or no, so the probability of A is the same. That's the meaning of that. So we can combine two events by union or intersection. This is read as or. This is the union. Union. We call this union or. So we use for union for this simple. This is union. Union. Okay. So the probability of A or B, if union B is equal to, as we said, probability A plus B minus the intersection between, this is the intersection between them. This is called Venn diagram. This is A, this is B. Okay, so probability of A plus B, you add them and remove the area which is in common between them. We say this is intersection. This is the intersection. If not B, 1 minus BA. The total probability is equal to 1. Always equal to 1. The total probability is equal to 1. It cannot be more than 1. Probability cannot be more than 1. No way. It cannot be less than 1. So the probability should be a number between 0 and 1. It cannot be 1.1. It cannot be negative 1. Okay. If the probability of finding an error on an income tax return is 0.04, what's the probability of finding a free error? Is 1 minus this, as we said. Random variables are numerical description of outcome. A random variable is function that assigns numerical value every possible outcome in the same space. We say the probability of x is equal to this. So x is a random variable. Important probability distributions. So we have what we call discrete distributions. We have continuous distribution. The discrete, from the statistics, we know discrete means like it should be integer number. We're talking about cars, peace, people, students, patients, okay? So we will cover the binomial and the Poisson distributions. For the continuous, it could be any number. It could be time, weight, length, width, whatever, and the exponential. So these are the four probability distributions we are going to cover in this chapter. The first one is the binomial distribution. As I mentioned, the binomials create the probability of obtaining exactly success in a sequence of identical experiment called trial. So if I have a bucket and I have, like, for example, 10 pieces in this bucket here, or balls or whatever, and they have different colors. So I say, okay, what is the probability of drawing one of them and it's red? This is binomial. Okay, it's a success in sequence of identical experiments. One thing you need to know first before we start calculating the binomial, we have this symbol, we need to see this, and you should know this. What's this? Ask. What's this symbol? Oh, we only have two students. The rest of the students, they left. What's this symbol? This is called factorial. This is how we calculate the factorial. And you can calculate it using the 1 factorial is 1, 0 factorial is 2 factorial is 2 times 1. Okay, I put all the examples for you and the solutions for the binomial, for the Poisson, for the other distributions. In both, you see here, I solved this example in by using the formula and using the Excel. So you need to go over all these slides, read the examples, and you let me know if you have any questions. And there are examples. This is the Poisson distribution formula. E to negative lambda lambda x divided by x factorial. And I provided some examples in the Excel here. There are some binomial worksheet, normal examples in Excel here, normal tables, and t-tables. You will need all of these. If you have any questions, please let me know. Contact me. I should be able to help you. I will post this recording for your record on the class website under here. Will be the last item here. Okay. Any questions? Okay. Thank you. Have a wonderful break. I'll see you after the break. Thank you.